Today we're just going to be going over our lesson on circles. So I just really quickly want to go through just some quick vocabulary. In your notes we talked about a circle having, there's a radius, which is from the center point to any of the outer edge. We would call this a radius. We normally label it with a lowercase r to show our radius. And then if you extend it from one side to the other, if you have a line that goes through the midpoint and goes from one part of the circle to another and it crosses through the midpoint, we actually call that, I'm going to dot this line here, we call that the diameter, and we normally label it with a letter D. So we've kind of got two different things that we need to know here. We've got a radius and a diameter. We also had some formulas that we learned. We talked about the circumference formula. Circumference is the area around a circle, or not the, but like the perimeter, not the area, but the perimeter around a circle. And so circumference, we had two different formulas. We said pi d, so we can do pi times diameter, which is this long inside length here, or circumference can also be 2 pi r, since we can multiply r by 2, since 2 r's equal d, we could do 2 times r, 2 r's equal d, 2 pi r is also circumference. And then the last formula that we learned in our notes for today was area equals pi r squared. And the way that I keep these two formulas separate, because this one and this one look really, really similar. 2 pi r and pi r squared. They've all got the same symbols and numbers involved. I always think about area squarea. So I kind of say that silly thing in my head. Area is the one where things are squared. Circumference is not. So area is equal to pi r squared. So I'm just going to go through a few quick examples here with you just to talk through and make sure that we've got the concepts from today's lesson. If I have a circle and the radius is 12 feet, and I asked you to find the exact circumference, whenever we talk about circumference and area, I'm going to be talking about these two words, exact and estimated. Exact always just means in terms of pi. So they want you to leave pi in the answer when it says exact. Pi will be part of your answer. And so circumference, remember we had two different formulas. We had pi times d, or we had 2 pi r. In this case, they're giving us the radius. So I'm going to choose this formula and say that circumference equals 2 times pi times 12. The commutative property of multiplication says I can multiply in any order, so 2 times 12 is 24, and then I can say 24 times pi is 24 pi. The exact means they want it in terms of pi, so my circumference is 24 pi feet. That is the distance around the circle. The label is like a perimeter, it's a length. If I were to put a string around the circle and then I were to cut that string and lengthen it all the way out, it would be 24 pi feet. So we talked about exact circumference. We also talked about area, and we talked about estimating. So this next one I'm going to ask you to estimate area, and I'm going to have you round to the nearest tenth. And so I've got a circle here, and this time I'm going to give you the diameter, and it is 32 centimeters. So our formula for area is area equals pi r squared. Remember, area squarea. And before I do this, I have to figure out what r is, because they gave me the diameter. I have to figure out what my radius is. My radius is always half of the diameter. So 32 divided by 2 is equal to 16. So my radius is 16. This is my diameter. My radius is 16, because 16 plus 16 would give me 32. So area equals pi times 16 squared. Then I'm going to pull out my calculator and do 16 to the second power is 256 times pi. If they wanted this in exact terms, we would leave it as 256 pi. But this time we're estimating to the nearest tenth. So if you have a scientific calculator, you can multiply by pi. If you don't have a scientific calculator or don't have the pi button on your calculator, you can always multiply by 3.14, which is what we're going to be doing in today's lesson. And then that gives us 803 and 84 hundredths. To round that to the nearest tenth, I'm underlining the 8 in my tenths place. It looks one place to the right. The 4 tells my 8 to stay the same. And so my area for this circle is 803 and 8/10 centimeters squared. So this is my area for this circle. Another thing that we did in your notes was they gave you two circles, one inside the other. It looked like this, and they said, okay, this one has a radius of 2, and this one has a radius of 7, and then they shaded this outside edge here, and they said, what is the area of this circle? And if we asked for the exact area, we're talking about in terms of pi. And so remember, area is equal to pi r squared. What I'm going to do is I'm going to find this big circle's area. I'm going to find the whole area of it. So that would be 7 squared times pi. And that area is 49 pi exact. And then I'm going to find this middle area, and I'm just going to subtract it from that whole to get what's shaded around here. So the area of the small circle is pi times 2 squared, which is 4 pi exactly. And what I'm doing there is I'm just like erasing the center out. I'm taking like the middle out of a donut here. And I've got all this outside edge. So I started with 49 pi. I took away 4 pi. And so the area of the shaded region is 45 pi exactly. If I wanted to estimate that, I could pull out my calculator and I could do 45 times pi or 45 times 3 14/100ths, and that would give me the estimated area of the shaded part of this circle. So we've got two big differences here. We've got exact, which always means in terms of pi, and estimated, which means we use 3.14 or the pi button, and then we round to the nearest tenth or hundredth or thousandth, whatever it's asking us to do there. We've got circumference, and we talked about the formulas pi times d or pi r, 2 pi r, and then we've got area, which is area equals pi r squared. So we've kind of got a couple different things going on, and in order to do all of this, we have to know our definitions of radius and diameter. The radius is always half of the circle, so it's the distance from the midpoint to the edge of the circle, and then the diameter is always it's two radiuses put together. It's a line that goes from one edge of the circle to the other and goes through that midpoint. And so the very last thing I'm going to do with you is a critical thinking skill. If I told you that a circle had a circumference of 32 pi and asked what is the estimated area, and we're going to talk about to the nearest tenth for today's purposes, we would really have to think through some critical thinking here. And so we did one like this in your notes, but I just want to talk through another example here. Remember that our formula for circumference equals pi d or 2 pi r. In this case, I have one number with pi, so I'm going to assume that if my circumference is pi d, I can plug this in here. 32 pi equals pi times d. I know then that my pi's kind of cancel out here if I divided both sides by pi. And d, my diameter of that circle, is 32. So once I know that my diameter is 32, now I'm working backwards to see what is my area. And I know that my area formula is equal to pi r squared. And so now from 32 I have to find the radius. In this case, 32 divided by 2 is 16, so my radius is 16. My area is 16 squared times pi. So I'm going to put that in my calculator, 16 times 16 times 3 14/100ths. And I get 803 and 84/100ths. If I wanted to round this to the nearest tenth, I would underline my tenths place, look one place to the right. The 4 tells my 8 to stay the same. And so the estimated area is 803 and 8/10. They didn't give us a label. Units squared. And that is my area. So there's some critical thinking that goes on there too, which we can review more, but I just wanted to give you a brief mini lesson of all the things you did in your notes and try and clarify a few common misconceptions. The big thing here that we have to keep straight is what does estimated mean and what does exact mean. And so in the IXL activity today, you're going to be doing mostly estimated areas and circumference, and then in the quizzes activity, I'm going to ask you to know the difference, just like I will on the exit slip later on when you do 3 on your own.